What do you do when reality stops following its own rules? In the silence between stars, 13 billion light years away, something is watching us not with eyes, but with truths too strange for comfort. The James Webb Space Telescope, humanity's most advanced cosmic sentinel, looked into the ancient dark, and what it saw should not be possible. The universe is breaking its own laws. Please like and subscribe, because this journey will change how you see our place in the universe. Prepare yourselves. We begin. For decades, cosmology was a clean equation. The Hubble Space Telescope gave us a measurement of the universe's expansion, and our models, our sacred math agreed. Like puzzle pieces locking into a cosmic mosaic, it all made sense. Expansion was constant, predictable, elegant, until James Webb opened its eyes. The data poured in like whispers from the edge of creation, and the equation shattered. Webb confirmed the worst fear. The universe isn't expanding at one speed. It's stretching in two different directions, at two different rates, depending on how you measure it. Imagine blowing up a balloon, but the top expands twice as fast as the bottom. That's not how physics works. That's not how reality works. And yet, it island, they call it the Hubble Tension, but that name is a euphemism, like calling a supernova a bright event. This isn't tension, it's a rupture, a rift in the mathematical fabric of everything we thought we knew. For the first time, the cosmos gave two different answers to the same question: how fast is the universe expanding? When we measured ancient light, the cosmic microwave background, a whisper from the moment the universe first became transparent, we got one number. When we measured distant pulsating stars, known as Cepheid variables, we got another. And the difference wasn't minor, it was catastrophic. So the scientists double-checked their tools, calibrated their instruments, measured again, over 1,000 Cepheid stars, across 5 galaxies, stretching 130 million light years, and the contradiction remained. The universe is not behaving like the neat clockwork machine we believed it to be. It's asymmetrical, anomalous, and alive with contradictions. Let this land. If expansion rates are inconsistent, then our entire model of the universe is built on a cracked foundation. Age? Wrong. Size? Uncertain. Destiny? Unknown. It's as if we've been reading the universe's story backward, and now Webb has flipped the book around, revealing a plot twist we never saw coming. Enter dark energy. This invisible force, the ghost in the equations, was already strange. It's what causes the universe to expand faster and faster, like gravity in reverse. But Webb's data suggests something even more troubling. Dark energy may not be constant. It might behave differently in different regions of space. Some parts of the universe could be pulling away from others at accelerated speeds, cosmic rifts tearing space-time apart like ancient paper. Webb didn't just take photos of galaxies, it photographed a physics breakdown. One of the lead researchers, Adam Rees, summed it up with chilling precision. With measurement errors ruled out, what remains is the real and exciting possibility that we have fundamentally misunderstood the universe. Exciting? Maybe, but only in the way that discovering a crack in the hull of your spaceship is exciting. Here's the existential punchline. Our laws of physics may not be laws at all. They may be local customs rules that work here, but not there. Truths that held firm in our corner of the universe, but fall apart under the weight of ancient starlight. If true, this changes everything. From the way we model supernovae, to how we estimate the birth of stars, to the very possibility of a multiverse. Think about that. If different regions of space expand differently, if different laws subtly apply, then perhaps our universe is not singular, but one ripple in a much larger, stranger sea. And still, Webb peered deeper, not just through space, but through time. It saw galaxies that were too old, too big, too bright, existing at a time when they shouldn't have. And soon, the expansion crisis, this fracture in the cosmic fabric, would become just the first crack in a shattering mirror. But we begin here, with the broken rhythm of cosmic breath, a universe expanding like a heartbeat gone irregular, a pulse that no longer matches the music we wrote for it. What happens when the metronome of reality starts skipping beats? You listen closer, you hold your breath, you wonder, is the universe trying to tell us something? How did ancient galaxies grow old before the universe itself was young? Out beyond the Big Dipper, in a patch of sky so empty it was thought to be cosmic silence, the James Webb Space Telescope focused its infrared gaze. What it found was not silence, it was defiance. 6 galaxies, enormous, mature, shining with impossible light, stared back from the dawn of time, shattering every rule of how the universe was supposed to unfold. They were too big, too bright, too old, and they weren't supposed to be there. In the standard story of cosmic evolution, the early universe was chaos, hot, dense, wild. Matter was scattered, barely clinging together. Gravity was weak, time was short. The first billion years were supposed to be cosmic infancy, a period of slow, stumbling growth. But these 6 galaxies, they were titans, each one the size of our Milky Way or larger, each containing tens of billions to over 100 billion stars. And they existed when the universe was only 3% of its current age. That's like finding a towering redwood fully grown just weeks after planting the seed, like watching a mountain form overnight, like meeting an adult version of a child who hasn't been born yet. Astrophysicist Erica Nelson called them universe breakers, and the name stuck, not just because they broke the rules, but because they broke the story. The standard model of galactic evolution is simple. Small clouds of gas slowly gather, gravity pulls them tighter. Over millions of years, stars begin to ignite. Galaxies collide and merge, growing gradually into the majestic spirals we see today. But these 6 galaxies fast-forwarded the cosmic script. They didn't crawl, they sprinted. They didn't evolve, they exploded into existence, fully formed, shining, massive, as if the universe skipped chapters to get to the climax early. How? That's the question keeping scientists awake at night. To reach these enormous sizes so early, these galaxies would have had to form hundreds of new stars every single year, for hundreds of millions of years, all while the universe was still cooling down from the Big Bang. For comparison, our Milky Way manages to form only 2 stars per year. These ancient monsters were stellar factories, producing stars at speeds that physics says should be impossible. And their light, stretched red by billions of years of cosmic expansion, wasn't just dim, it was blinding. They shone like lighthouses across the abyss of time. And they weren't alone. These 6 were just the beginning. Webb has found more galaxies glowing from the early universe, with no clear explanation. According to our models, they shouldn't be there, but they are. So the models must break. Some scientists suggest dark matter might be the culprit. Maybe it clumped faster than we thought, pulling gas into tight webs and triggering starbursts at unprecedented rates. Others whisper the possibility that our understanding of gravity itself may be flawed, that in the early universe, gravity behaved differently. But each new explanation demands we rewrite the laws, stretch the equations, redraw the cosmic map, because these galaxies didn't just grow fast, they organized fast. They had structure, form, order, in a universe that was supposed to be chaos. Let that sink in. We thought the universe began in formless fire and slowly matured into beauty. But what if beauty was there all along? What if order isn't the outcome of time, but the seed from which time itself unfolds? These galaxies suggest something far deeper, that the cosmos may have been primed for complexity from the very beginning, that the rules we believed in slow growth, gradual development, cause and effect may only apply after the first symphony was already written. Here's the twist. When scientists modeled the early universe, they expected to find baby galaxies small, lumpy, chaotic. But instead, they found galaxies that had already lived. They weren't infants, they were survivors. So what came before them? What kind of universe gives birth to giants in its infancy? Perhaps one where the first few 100 million years weren't slow, they were violently productive. Perhaps the early cosmos wasn't a nursery. It was a battlefield, a forge, a crucible. If that's true, then everything we've ever believed about how structure forms must be questioned. Galaxies may not be passengers in the expanding universe. They may be architects of it, shaping space as much as being shaped by it. And here's the truly existential part. If complexity, if intelligence even can arise this early, under such pressure, in such heat, what else might have bloomed in that first billion years? What ancient forces? What forgotten civilizations? What buried lights in the dark? These 6 galaxies are not just anomalies. They are warnings that the universe is older, stranger, and more eager than we thought, that it does not wait for permission, that it creates without apology, that it writes its own history in fire and light and dares us to keep up. What do you call a shadow that comes before the light? Deep in the early darkness of the cosmos, before galaxies had bloomed and stars had stitched themselves into constellations, James Webb saw something it shouldn't have. Something massive, something ancient, something alone, a black hole not in the center of a galaxy, where it belonged but floating naked in the void. No spiral arms, no host of stars, no swirling disk of gas, just raw, unimaginable gravity, untethered. They named it COS 87259, but among scientists, it earned another name, the naked monster. In our model of cosmic evolution, black holes are born from death. A massive star collapses under its own gravity, triggering a supernova. What's left behind is dense, hungry, and invisible, a black hole. Over time, these stellar corpses grow, colliding and consuming matter until they become supermassive, anchoring galaxies like cosmic keystones. But COS 87259 doesn't fit that story. It appeared in the universe just 600 million years after the Big Bang, far too early for any of this to have happened. There weren't supposed to be enough stars yet, let alone enough time for them to die, collapse, and merge. And worse, COS 87259 has no galaxy around it, no visible home, no nest of light, just the gravitational womb. Let's put this in perspective. This black hole contains the mass of 50 million suns, compressed into a region smaller than our solar system. If Earth were the size of a marble, COS 87259 would still be invisible, and yet it would weigh more than every marble ever made, multiplied by the stars of 100 billion galaxies. It should be impossible, but it's not alone. Webb has found hundreds of these isolated red dots, potential black holes, scattered across the ancient cosmos like cosmic landmines. They're not just unexpected, they're paradoxical. They glow with the light of matter being shredded, gas spiraling in, superheating, and screaming before it vanishes forever. But there's nothing else around them. No galaxy, no star formation, just hunger. 3 theories have emerged to explain them, each more unsettling than the last. Direct collapse. Maybe these black holes didn't come from stars at all. Maybe massive clouds of gas in the early universe skipped the stellar phase and collapsed straight into darkness. No light, no warmth, just gravity born raw, supercharged growth. Or maybe smaller black holes somehow consumed matter at impossible speeds 40 times faster than the limits of physics should allow, growing like tumors in a newborn cosmos. Primordial black holes. The most chilling theory of all. What if some black holes didn't form after the Big Bang, but during it, formed in the first fractions of a second, as space-time convulsed with quantum chaos? Born from density fluctuations in a boiling universe where some regions became so dense, so fast, they tore holes into existence not from matter, but from math itself. If this is true, then COS 87259 is not just ancient, it is pre-galactic, pre-stellar, a relic from the before, from a time before time had rules. And if black holes like this existed from the very beginning, they've had 13 billion years to grow. They've been lurking in the shadows, waiting for stars and galaxies to form, and then feeding. They are older than light itself. Let that land. This isn't just about strange objects. It's about rewriting the origin story of the universe. Because if black holes came first before stars, before galaxies, before light, then everything we thought was primary becomes secondary. Stars didn't make black holes. Black holes may have made stars. Galaxies didn't shape the void shaped galaxies. In this story, darkness isn't the absence of light, it's the parent of it. And if these naked monsters were the first architects, then their fingerprints are everywhere, in the spin of galaxies, in the ripples of space-time, in the accelerated expansion of the cosmos, perhaps even in the structure of consciousness itself, for what is awareness but a gravitational center pulling in experience? But it gets darker, because if black holes formed before stars, then they didn't need light, they didn't need heat. They existed in a universe that was cold, dark, and silent, and they thrived. They are the ultimate survivors, which raises a terrifying question. Could some of them still be wandering? Invisible, undetectable, drifting between galaxies, waiting. Some astrophysicists believe primordial black holes might still be out there, even here, in our own galaxy. Dark passengers that predate the Sunday, ancient ghosts passing through planetary systems, black marbles in a sea of stars, and we'd never know until it's too late. The discovery of COS 87259 and its naked kin doesn't just challenge the timeline of the cosmos, it challenges its hierarchy. We thought galaxies were the foundation. We thought stars were the builders. We thought light was the beginning. But maybe we were wrong. Maybe the universe was born not in fire, but in silence. Not in light, but in shadow. Maybe the first sound was the absence of a sound, the intake of gravity, as it closed its fist for the first time. And maybe, somewhere out there, one of those ancient fists is still closing. Right now, what if the first lanterns in the universe were black holes? For most of human history, we've told ourselves a simple story. First, there was darkness, then came light. Stars ignited, galaxies spun, and the night sky bloomed. But James Webb is rewriting that story line by line, and now it offers us a twist so bold, so inverted, it feels like a riddle whispered from the mouth of the void itself. What if the first light came not from stars, but from monsters? Traditionally, light is life. It's the sign of warmth, of beginning. We look at stars and call them our ancestors. We trace our atoms to their hearts. We believe their fires lit the cosmic stage on which life could one day emerge. But as Webb peers into the earliest chapters of existence, the first few 100 million years after the Big Bang, the stars aren't there yet. Not in the numbers they should be. Not shining as brightly as we expected. Instead, what the telescope finds are points of furious brightness, compact and blinding, but with no surrounding galactic structure. No neighborhoods, no spiral arms, no stellar cities. Just radiation, just power, just darkness, glowing. How is that possible? Because when gas falls into a black hole, when it spirals inward, crashing into itself, accelerating to near light speed, it doesn't just vanish. It screams. The friction is so intense, the temperature so extreme, that the infalling matter lights up just before it disappears. It's a cosmic paradox. The darkest objects in the universe can be its brightest beacons if they are feeding, and Webb found them feeding monsters, glowing from their gravitational feasts, scattered throughout the early universe. The terrifying implication? These black holes may have lit the cosmos before the first stars ever did. This flips everything, because if black holes were the first sources of light, then the universe's birth was not a quiet unfolding into gentle starlight. It was a frenzy of hunger, not stars creating beauty, but gravity creating fire through destruction. Scientists call these candidates primordial black holes, formed not from dead stars, but from density fluctuations in the first seconds of the universe's life. Imagine the cosmos as a boiling cauldron of pure energy, erupting with violent unevenness. Some pockets stretch, others collapse. And in those collapsing regions, before there were atoms, before there were photons, gravity dug pits so deep, not even time could climb out. Black holes were not the aftermath. They were the architects. And they fed. On what? On gas, on dust, on chaos. They drank from the universe's first offerings, and in their feeding, they ignited, they shined, not gently like a star, but violently pouring out high-energy radiation that cut through the fog of the infant cosmos. They were engines, lighthouses, warnings. From Earth, across 13 billion light-years, we now see their light, compact, blazing, unreasonable. These signals masquerade as starlight, but they're not. They're black holes, pretending to be stars. Here's the tell. Stars produce broad, balanced spectrums. Black holes, in contrast, emit hard X-rays, ultraviolet spikes, violent flares. They glow because they're consuming. And when Webb isolates these spectral fingerprints, the pattern emerges. Too many of the bright lights from the early universe are point-like, too sharp, too violent. They're not galaxies. They're primordial furnaces with bottomless stomachs. And here's what really shifts the paradigm. If these monsters lit the universe before the stars, then the first wave of cosmic light didn't bring order. It brought destruction. Radiation from these black holes would have sterilized entire regions, heating and ionizing gas, delaying the birth of stars rather than encouraging it. In other words, the universe's first breath was a scream. Yet paradoxically, this violent light made the stars possible. By flooding regions with energy, by stirring the cosmic soup, by breaking apart molecules, these black holes may have primed the environment for the next phase. Stars, galaxies, planets, and eventually, us. The darkness that came before the light was not a void. It was a crucible. There's poetry in this. We often think of creation as gentle, as divine, as pure, but the universe doesn't care for our myths. It creates through collision, through collapse, through devouring. And sometimes, what destroys is what makes creation possible. So now, we must ask, what does it mean that our universe may have been lit by predators? That gravity, not light, wrote the first words? That the first visible structures were not life-giving stars, but world-ending black holes? It means our origin story is darker, more violent, more majestics. It means we are the children of chaos, shaped by forces that do not love us, but that gave us the chance to love, to see, to wonder. It means that when we look into the night sky and see ancient light, we might in truth be looking into ancient hunger. And yet, here we are, born of that chaos, awake, asking questions, witnesses to a story where the first chapter was not light emerging from the dark, but darkness setting the stage for the light. The universe didn't begin with illumination. It began with a feast. What happens when galaxies collide and birth a black hole from nothing? Out there, in the deep sky, past the comfort of constellations and the warmth of stars, two galaxies are locked in a collision that looks more like a cosmic ballet than a cataclysm. But don't be fooled. This is not a dance. It is a collapse, a transformation, a paradox made visible. At the heart of this collision, James Webb saw something that breaks every rule we've ever written about how black holes form. Not the aftermath of stars, not the anchor of a mature galaxy, not a silent remnant quietly spinning in the dark. No, what Webb saw was a black hole being born in real time, not from the death of a star, but from the sheer weight of gas collapsing between two colliding galaxies. They called the system the Infinity Galaxy because of its eerie shape, two glowing red nuclei, each surrounded by shimmering rings, forming a figure 8 inches the sky, the symbol of eternity. But this wasn't eternal. This was impossible. In every physics textbook, the rules are clear. Black holes form from stars. Stars form from gas. Galaxies form from stars. And black holes, the great devourers, sit at the center of galaxies, not in between. But in the Infinity Galaxy, Webb found a black hole floating in gravitational no man's land, suspended in the gas bridge between the two galactic cores. It wasn't in one galaxy, it wasn't in the other. It was in the middle, a cosmic orphan, a god without a temple, and it was growing. The mechanism is something scientists have only theorized about, never observed. It's called direct collapse. Picture it. When galaxies crash into each other, they rip tidal streams of gas, loose rivers of hydrogen and helium, hundreds of thousands of light years long, surging across space. Now imagine if one of those rivers becomes so massive, so dense, so cold, that it collapses under its own gravity before it can even form stars. No supernova, no light, just gravity folding in on itself and birthing a black hole fully formed. A monster born in a single breath. And that's what Webb saw. Streams of gas from the two colliding galaxies, crushed together by tidal forces, forming a cloud so heavy that it skipped the entire stellar phase and went straight to darkness. This is gravitational collapse without evolution, a shortcut to oblivion. The consequences are staggering, because if this process happened here now, in the modern universe, then in the early universe, where galaxies were smaller, denser, and more violent, it must have happened all the time. This could explain why James Webb has found so many massive black holes so early in cosmic history, far too massive for the time they've had to grow. Direct collapse means these monsters didn't start small. They were born big, born ancient, and here's what's even more shocking. This black hole isn't passive. It's feeding right now on the gas bridge between the galaxies. Radio waves captured from the system show intense energy emissions exactly where Webb placed the black hole. It's devouring matter, heating it to millions of degrees, releasing radiation in a gravitational scream that stretches across intergalactic space. You are watching a black hole grow in a place where no black hole should be. It is the birth of a paradox, and the infinity galaxy, this twisted double spiral, is more than just beautiful. It's a laboratory, a glimpse into how the most powerful structures in the universe are made not through peace, but through collision, not through time, but through rupture. This system is not just birthing stars, it's birthing questions, because if black holes can form this fast, if they can emerge from gas instead of stars, if their births can be triggered by collision instead of death, then what else can the universe do that we haven't imagined? What other shortcuts has it taken? How much of what we call evolution is really just collapse wearing a mask? Direct collapse black holes force us to rethink the role of violence in the cosmos. We've always known that destruction and creation are intertwined. Supernovae forge elements. Collisions birth new stars. Entropy opens room for complexity. But this is different. This is destruction as a starting point. Collapse is the first word. A universe that doesn't wait for life to live before it dies, but where death itself is the genesis. And perhaps most unsettling, this process doesn't require a special kind of matter. It doesn't require stars. It doesn't even require time. All it needs is gravity, density, and a little chaos. Which means black holes may be more fundamental than galaxies. They may not be byproducts of evolution, they may be triggers of it. Galaxies might not host black holes. Black holes might summon galaxies. Let that sink in. The things we thought of as destroyers might actually be creators. The things we feared as ends might have been beginnings all along. The infinity galaxy is not just a name, it is a symbol of a loop with no clear start or end, of a universe where collapse births creation, and creation begets collapse. It is a reminder that the cosmos does not play by our rule. It writes its own, in fire, in shadow, in spirals of eternity. What do you call a planet with no star but a voice that speaks across the void? Out in the Orion Nebula, where stars are still being born in clouds of cosmic fire, James Webb has found something unexpected. Not stars, not galaxies, but wanderers, orphaned planets, hundreds of them, worlds without suns, without orbits, without homes, and stranger still, some of them are not wandering alone. They are drifting in pairs, massive gas giants, the size of Jupiter, silently orbiting each other as they move together through the darkness, far from any stellar system. And from some of these cosmic couples, radio signals are emerging. Let's pause and absorb that. These are not planets as we know them. They're not circling stars. They're not warmed by sunlight. They're not part of any solar family. They are castaways flung from their birth systems in gravitational chaos, now drifting through interstellar space, locked in orbital dance with a companion. Alone, cold, but not silent. They are speaking in pulses of high-frequency radio waves, and what they're saying, we don't yet understand. Scientists call them jumbos, Jupiter mass binary objects. They were never expected. In fact, planetary science said they shouldn't exist at all. Planets form in disks of gas and dust around newborn stars, slowly building up through accretion, gathering mass until they ignite atmospheres. That's the script. But these never read the script. Or worse, they were written out of it. Ejected, abandoned, left to wander, and now they've paired up, like survivors of a shipwreck, clinging to each other in the middle of an ocean with no land in sight. Some orbit each other at vast distances, 400 times the Earth-Sun distance. Others are closer, but each pair is alone in the darkness. No Sunday, no solar flares, no warmth, just the whispers of magnetism and the cold tension of gravitational embrace. And somehow, those whispers turn into radio signals. Here's where it gets weirder. When astronomers pointed sensitive radio telescopes at these jumbos, they didn't find the usual magnetic emissions we expect from gas giants. Instead, they heard something new, high-pitched, gigahertz frequency bursts thousands of times higher than FM radio. Not random noise, not static, but patterns, flickers, flashes, bursts, some consistent, some erratic, some utterly inexplicable. These are not the signals we'd expect from planetary magnetic fields interacting with interstellar particles. These are unnatural in their strength, unprecedented in their frequency, and unnerving in their complexity. So what's causing them? The leading theory is this. When two massive objects orbit each other in isolation, their magnetic fields begin to tangle, twist, collide. It's like rubbing two giant wires together across a galactic battery friction on a cosmic scale. This interaction generates powerful electrical currents, creating auroras and emissions far more extreme than anything in our solar system. Imagine Jupiter's magnetosphere turned up 1,000-fold. Imagine lightning storms that make Earth's most violent hurricanes look like a whisper. Imagine magnetic loops so large they could swallow entire planets. That's the kind of system we're talking about. And yet, that doesn't explain the variation. Each jumbo pair produces a different signature. Some pulse like clocks, others erupt randomly. Some fade in and out like a message trying to be heard through static. Are they natural? Almost certainly. Are they understood? Not even close. And that opens the door to a darker, stranger thought. What if these signals are not just side effects? What if they're the story? What if the real anomaly isn't that these planets exist, but that they speak? Of course, we don't mean language in the human sense, but patterns are language. Rhythms are communication. The universe speaks in fields and pulses and waves, and when something speaks that loudly, we should listen, because every signal tells a story, and these are the stories of worlds that were cast out. Planets that formed were torn from their suns, and now drift still clinging to each other with magnetic fields strong enough to scream across the void. But perhaps the most haunting part isn't that they speak, it's why they exist at all. If James Webb found over 500 of these objects in just one nebula, how many are there in the galaxy? Millions? Billions? How many solar systems have failed? How many planets were born only to be ejected in gravitational wars? Each jumbo is a tragedy. A solar system that broke, a planet that never saw daylight, a world that lost its home before it ever had a chance to begin. And yet, they endure, they dance, they drift, they send out signals. A cosmic SOS? A scream? A song? We don't know yet. But they remind us of something deeply human, that even in exile, even in silence, something wants to be seen. James Webb didn't just find orphaned planets. It found witnesses to the violence of planetary birth, to the fragility of orbits, to the loneliness of the cosmos. And through the cold silence of space, they are still whispering. What happens when a planet is born without the ingredients for life? In a stellar nursery called NGC 6357, James Webb turned its gaze to a young star system still wrapped in the dusty veil of its creation. What it found was not awe-inspiring beauty, though that was there too. What it found was a mistake, not a flaw in the telescope, not an error in the data, but a mistake written into the cosmos itself, a planet-forming disk that seems to have forgotten how to build worlds like ours. The star is named XUE-10, young, bright, surrounded by swirling gas and dust, the raw materials of planets, the place where rocky Earths are forged. But something is missing: water, and in its place, carbon dioxide. Thick, dominant, unexpected. A planet is forming here, but not the kind we know. This is a betrayal of our most basic assumptions. Every planet-forming model in astronomy starts with the same ingredients: silicate minerals, ice, and water vapor, lots of it. In the inner disk, where temperatures are high and rocky planets like Earth are born, water is supposed to be everywhere. It seeds the chemistry of life. It helps cool and shape planetary atmospheres. It is the foundation, but Webb's infrared spectrograph showed the opposite. The inner disk of XUE-10 isn't just low on water, it's nearly devoid of it. Instead, carbon dioxide is everywhere, thick, saturated, piling up in regions where oceans should begin. It's like stumbling upon a bakery where every recipe uses ash instead of flour. The dough still rises, but you don't want to taste the bread. And yet, planets are forming here, which raises a terrifying possibility that planetary systems like ours, rich in water, chemistry, and the chance for life, might be the exception, not the rule. That the galaxy is filled not with Earths and potential Edens, but with dry, carbon-heavy wastelands, worlds made wrong. Two theories now battle to explain the nightmare Webb has uncovered. Theory 1. Radiation sterilization. It's possible that intense ultraviolet light from nearby massive stars has broken apart water molecules in the disk, a process called photodissociation. When this happens, hydrogen, the lightest element in the universe, escapes, gone forever, leaving only oxygen, which combines with carbon to form carbon dioxide. In this version of the story, water wasn't missing. It was murdered, killed by the very starlight that nurtures creation. Theory 2. Dust gone wrong. The other possibility is even stranger. Maybe the dust grains in the XUE-10 disk are coated not with water ice, as they should be, but with carbon dioxide ice. That would mean the raw chemistry of the system is broken from the beginning, that before anything even formed, the recipe was already corrupted. A planet built from that dust won't just be dry, it will be fundamentally alien. Atmospheres that suffocate, soils that reject water, clouds made of poison, not rain. A planet like this might form oceans of liquid CO2 under crushing pressure. It might grow dense, acidic clouds that never break. It might know no seasons, no weather, no life. It would be a mirror of Earth, twisted and inverted. And now we must ask, how common is this? Because if one young star system forms dry planets, how many more are out there? How many potential Earths are silently building into dead worlds before they even get a chance to try? The implications stretch far beyond this one system. Webb has revealed a disturbing truth. Planetary formation is not standardized. There is no universal blueprint, no cosmic quality control, no guarantee of water, no guarantee of life. The cosmos is not building Earths on an assembly line. It is experimenting, and some of those experiments fail. So what does that say about us? About our world? We think of Earth as average, typical, a rock with some water, spinning around a star. But what if Earth is a fluke? What if we live on the only success in a universe of chemical tragedies? That would make water not just precious, but miraculous. A chemical accident that gave rise to seas, storms, rivers, and eyes to behold them. XUE-10 forces us to face a darker vision of the cosmos, one where not all stars raise their children the same way, one where some stars burn too hot or too close, or are surrounded by chaos that strips their planets before they are born, one where most planets are silent not because life is rare, but because conditions were never right to begin with. A galaxy full of rocks, full of potential, but missing the one ingredient that makes the difference between a tomb and a cradle. Still, even in this dry place, something is forming. Even with poisoned chemistry, the laws of gravity pull dust into spheres, turn chaos into orbits, carve emptiness into paths. This planet may never know rain. It may never feel the cool touch of water, but it will still exist. It will still spin. It will still try, because even in failure, the universe creates. Even in broken recipes, something emerges. And maybe, just maybe, there are forms of life, strange, carbon-breathing, acid-loving life that could one day call these places home. We don't know, but we do know this. Earth is not guaranteed. Life is not the default. And James Webb is showing us, one dry world at a time, just how rare and how fragile our cosmic conditions truly are. What if a planet could breathe fire and rain metal? There's a world out there, so close to its star that its entire surface burns like a forge. Not metaphorically, literally. Its rocks melt, its minerals boil, its air is made of poison and heat. And somehow, against every law we thought we understood, it still has an atmosphere. The planet is called 55 Cancri E, and it's one of the most hellish places James Webb has ever seen. This is not just a hostile environment. It's a world that should not exist. And yet, it persists. Let's begin with the numbers. 55 Cancri E orbits its star at a blistering distance of just 1.4 million miles closer than Mercury, closer than any known habitable zone. It completes a full orbit in just 18 Earth hours. 1 year there is shorter than a day, and because it's tidally locked, the same side always faces its star, just like the moon always shows one face to Earth. That means one side of this planet is in eternal day, while the other is plunged into perpetual night. On the day side, temperatures soar above 4,000 degrees Fahrenheit, 2,200 degrees Celsius, enough to vaporize metal, enough to glow with molten light. This side is a sea of lava, a mirror of suffering. The night side, frozen, shadowed, a vacuum of silence. It is a world split in two, fire and ice, forever divided. And yet, James Webb discovered something no one expected. An atmosphere, thick, circulating, alive, made not of hydrogen or oxygen, not the breathable air we know, but of carbon monoxide and carbon dioxide, somehow swirling between day and night, refusing to vanish despite the brutal heat. This alone is impossible. By all logic, this planet's atmosphere should have been blown away billions of years ago by solar radiation. It should be a bare rock, scorched, silent and sterile. Instead, it breathes. And not only that, it replenishes itself. Scientists believe the explanation lies beneath the surface in the boiling interior of the planet itself. The extreme heat and tidal forces from its close orbit are doing something terrifying, cooking the crust from the inside out. Deep underground, volatile carbon-rich materials are vaporizing, rising, and erupting through volcanic activity. The result? A secondary atmosphere born not from ancient air, but from continuous geological outgassing. In simpler terms, the planet's own bones are steaming. Its own flesh is the source of its breath. It's as if the world is melting itself just to stay alive. This creates a feedback loop unlike anything we've seen. The interior boils, gases erupt, an atmosphere forms. The star blasts it with radiation. The atmosphere is stripped away. The interior boils again. Repeat, forever. It is a planet caught in a self-sustaining torment, a breathing machine built on fire and loss. But here's where things get even stranger. That atmosphere doesn't just sit there, it moves. Webb's thermal measurements revealed something remarkable. The night side of 55 Cancri E is warmer than it should be, which means energy is being transported from the molten day to the frozen night by powerful winds, likely moving at thousands of miles per hour. And what are those winds carrying? Rock. Vaporized minerals that boil on the day side are swept through the atmosphere, then condense on the night side and fall as rain. Not water. Molten silicate, liquid metal, droplets of rock. Imagine standing in darkness while iron rain falls from the sky, hissing on frozen ground, reforming into stone. This is not weather, it's alchemy in motion. What does this mean? It means atmospheres are not fragile things. It means they can survive even in hell. It means that planetary geology, not just distance from a star, can determine whether a world has air, even if that air is toxic, burning, shredding, alive. And that has implications far beyond this one planet. Because if atmospheres can persist here, in this furnace, in this death spiral, then what other worlds have we written off too soon? How many exoplanets have we labeled uninhabitable simply because they orbit too close or too fast or too wrong? If fire worlds can have clouds, if lava planets can have wind, if broken rocks can breathe, then maybe we've been looking for life in all the wrong places. Let's be clear, 55 Cancri E is not a candidate for habitability. Its atmosphere is deadly, its ground is liquid, its air would melt spacecraft. But what it shows us is something deeper than life. It shows us endurance, a planet that refuses to die, that bleeds and exhales and erupts just to stay whole, a world that challenges our ideas of what a planet can be. It is not a paradise, it is not a beacon of hope, but it is a monument to cosmic resilience. So the next time we define habitability, let's remember 55 Cancri E. Let's remember that planets are more than their temperature zones. They are stories, some beautiful, some tragic, some, like this one, written in fire. What if the oldest story in our solar system didn't begin here? It came from the dark, not from the outer reaches of our solar system, but from beyond it, a ghost, flung across the void by a star we may never know, traveling for billions of years in silence, until it crossed our path. Its name is 3I divided by Atlas, and it is not from here. This is not a comet like the ones we know, not a leftover from our solar system's dusty childhood, not a local relic of frozen gas and ancient rock. No, this object is interstellar. It came from the space between the stars, and its trajectory tells a chilling truth. It was never bound to our Sunday. It simply passed too close, veering into the reach of our telescopes for a fleeting moment, and then gone. But in that moment, we learned something profound. 3I divided by Atlas is only the third known interstellar object humanity has ever detected, after Oumuamua and 2I divided by Borisov, each one more puzzling than the last, each one rewriting our understanding of what drifts through deep time. But 3I divided by Atlas, it may be the oldest and strangest yet. Here's why. When scientists tracked its trajectory backward, they realized something unsettling. It had passed within 2 light years of multiple stars, over the course of the last billion years, like a pinball ricocheting across the Milky Way, nudged by invisible gravitational hands. And before that, it emerged from nowhere. No origin point, no parent system, no traceable past, just a cold, tumbling object, carrying the chemistry of alien suns. Some comets carry water, some carry carbon chains. 3I divided by Atlas carries secrets. Its spectrum suggests it is rich in complex organics, not unlike the building blocks of life. But these molecules formed in an environment older than Earth itself. Let that settle in. You are looking at matter that predates the Sunday. Matter shaped by different stars, different conditions, different rules. It's as if an ancient traveler from a forgotten corner of the galaxy just passed us a message in a bottle, and we almost missed it. Because here's the cosmic joke. 3I divided by Atlas is faint, silent, small, a fragment from long ago, drifting without purpose, never meant to be found. And yet Webb saw it, captured its light, measured its velocity, listened to its story. And in that story, we found a truth more haunting than alien contact. The universe is filled with ghosts, rocks from dead star systems, artifacts from ancient galaxies, travelers who outlived their makers and now wander unnoticed through the dark. These are not ships. They are not messages. They are memories. The memory of planetary systems that rose and fell before Earth was even dust. The memory of collisions, of exiles, of worlds broken apart and flung into silence. 3. I, divided by Atlas, is not rare. It is the first of millions, maybe billions of interstellar castaways, passing through our solar system every million years. Most we'll never see, but when we do, they whisper. And what do they whisper? They whisper that the universe is not tidy, that planets are not bound forever, that stars give birth to worlds and then lose them. They whisper that we are not the center, that we are not even special, that the materials that make up your hands, your blood, your thoughts may have once drifted like this, or worse, that they still do. Because if 3I divided by Atlas came here, what left us? What fragments of Earth, what debris from our own forming system are now sailing through alien skies? Could some distant civilization be watching a piece of us pass by, wondering where it came from? We think of our solar system as a closed room, a home sealed from the void, but it isn't. It's a bus stop on a galactic highway where the traffic moves at incomprehensible speeds and stories get lost in transit. 3I divided by Atlas is just the first traveler we caught, looking back at us, and what it says is simple, terrifying, and beautiful. You are not alone, not because others are watching, but because the universe is filled with pieces of the past we haven't met yet. James Webb didn't just see a comet. It saw a memory, older than our star, cut loose from time, floating blind through the dark. And in that memory, we see the future, because one day, when our sun expands, when Earth is vaporized, when our system becomes another ruin in space, something will survive, a piece of us, a rock, a whisper, and some distant eye on some distant telescope will watch it pass by and wonder, what if the first galaxies weren't galaxies at all? In the earliest moments after the Big Bang, there should have been nothing but chaos. A hot, dense fog of particles colliding and scattering, blind and wild. No stars, no structure, no galaxies, just darkness becoming light. According to our best models, it took hundreds of millions of years for the universe to cool, settle, and begin sculpting stars from hydrogen stars that would then gather into galaxies like islands rising from a cosmic sea. But James Webb saw something else. Not distant galaxies, not shining clusters, but red dots. Small, ancient, blazing, burning in a way that should not be possible. They are called little red dots, and they may be the oldest cosmic objects ever discovered. But what they actually are remains a mystery. Let's rewind. The redshift of light, the stretching of electromagnetic waves as space expands, is a cosmic clock. The more redshifted the light, the older the source. So when Webb detected a population of tiny, ultra-red glowing points at redshifts greater than 13, astronomers were stunned. This means we're seeing them as they were just 300–400 million years after the Big Bang. But here's the problem. They're too bright, too mature, too massive. They seem to have stellar populations, dust, and structure, the kind of complex architecture that shouldn't exist until much later in the timeline of the cosmos. In short, they're too old, too soon. If these are galaxies, they break every model we have. To form a galaxy this early, you need time for stars to ignite, time for matter to clump, time for dust and heavy elements to form through stellar death. But the universe hadn't lived long enough for all this to happen. Unless it happened faster than we thought, or something else entirely was forming. One possibility? These are not galaxies. They are direct collapse black holes, in disguise primordial monsters forming not from the gentle birth of stars, but from the catastrophic implosion of matter skipping the stellar phase entirely. Imagine a cloud of gas so dense, so violent, it doesn't bother making stars. It just collapses straight into a black hole, engulfing everything nearby. The energy released from such a collapse could light up the surrounding gas, making it appear like a galaxy even though it's a trap, a gravitational abyss dressed in glowing robes. If true, these red dots may be the first black holes, born before stars, before galaxies, before logic. Another possibility? There's something entirely new, a class of early universe objects we don't yet have a name for. Maybe early matter behaved differently. Maybe physics itself shifted in the first few 100 million years. Maybe dark matter played a more active role, binding gas faster than we expected. Whatever the explanation, one thing is clear. James Webb is seeing too much, too early, and the little red dots are the clearest symptom yet that the Big Bang timeline we trust may be incomplete. These objects raise deeper questions. Why are they so red? It's not just redshift. Some show excessive infrared glow, meaning something inside them is re-emitting light, perhaps from intense starbursts or black hole activity. Why are they so compact? They're not spread out galaxies, they're pinpoints, suggesting incredibly dense regions. Why are there so many of them? They're not rare. Webb is finding hundreds in deep fields. That's not an anomaly. That's a pattern, a signature from the primordial universe, a message from a time before structure, and yet we don't understand it. These red dots whisper, not in language, but in contradiction. They say, I am older than I should be. I am brighter than I have any right to be. I was here when the universe was still finding its shape. I am not what you think I am. They are cosmic imposters, wearing the masks of galaxies, hiding truths we're not ready to see. And maybe that's the real gift of the James Webb Telescope. Not answers, but better mysteries. Mature galaxies where none should exist. Black holes disguised as stars. Fragments of time dressed in colors we don't yet have names for. The little red dots are not just distant, they are profound, because they force us to ask, what is the earliest light, really? Are galaxies the first actors in the cosmic play? Or is there a prelude, a forgotten act that came before? We once thought the universe began simply, but now we see it was messy, violent, mysterious, filled with structures that defy sequencing. The little red dots are the first rebels of reality, and they are demanding a rewrite of the origin story. In their glow, we see not just stars, but the limits of our understanding, and perhaps that's the most important light of all. Not the one that shows us where we came from, but the one that reveals how little we truly know. What if the universe was spinning all along? Look up at the night sky. Everything seems calm, still, infinite. But what if we've been wrong? What if the cosmos, this vast, ever-expanding sea of galaxies, isn't drifting outward in perfect balance, but turning, subtly, relentlessly, like a vast whirlpool of space-time? Because now, there's evidence, faint, disturbing, beautiful. The universe might not be symmetrical. It might have a spin, and that spin could change everything. It began with a whisper in the data, a pattern hiding in plain sight. Astronomers analyzing deep-field galaxies noticed something odd, a small but statistically significant bias in their rotation. When you look at distant spiral galaxies across the observable universe, you'd expect them to rotate randomly, some clockwise, some counterclockwise, a cosmic coin flip. But James Webb, along with projects like Galaxy Zoo and the JADE survey, found something unsettling. More galaxies in certain regions of the sky are spinning one way, and in other regions, the opposite. Not a huge difference, but too large to be noise, too consistent to be coincidence, almost as if the entire observable universe is obeying a deeper directionality, a cosmic handedness. This shouldn't be possible. The cosmological principle, one of the bedrock assumptions of modern science, says the universe is isotropic and homogeneous at large scales. That means no special directions, no preferred locations, no cosmic north or south. But if the rotation bias is real, that principle falls apart, and in its place, a new picture begins to emerge, one where the universe might not be expanding equally in all directions, but spinning like a gyroscope embedded in space-time itself. This idea isn't entirely new. Decades ago, Scientists like Kurt Gödel proposed solutions to Einstein's field equations that allowed for rotating universes. These Gödel metrics described a universe that, instead of expanding uniformly, had a global angular momentum, a twist. In such a cosmos, strange things happen. Time loops become possible. Causality breaks down. The very structure of reality begins to curl in on itself. But Gödel's model was considered unphysical, too weird, too speculative. Now, it's not so easy to dismiss, because Webb is seeing hints that this twist might be real, and it goes deeper. If the universe is spinning, then everything inside it, galaxies, dark matter, light itself, is part of that rotation. Even you, your body, your thoughts, your time, caught in a cosmic swirl that began at the first instant of creation. And if the rotation isn't uniform, it means edges, places where the spin breaks, where reality itself might fracture. And here's where the theory turns terrifying and poetic. If the universe is rotating, and if that rotation increases with time, it might be because we're not inside a universe at all, but inside a black hole. Yes, let that sink in. Some physicists now suggest that the cosmos might not be expanding into nothing, but unfolding within the event horizon of a higher dimensional black hole. This would explain the cosmic microwave background's strange uniformity, the limits of the observable universe, the impossibility of seeing beyond the cosmic horizon, because beyond that horizon, there is no space as we know it, only the curved interior of a massive gravitational prison, and that prison might be spinning, just like all black holes do. In this view, the entire universe is a 3D projection on a rotating 4D boundary, a holographic swirl of energy, time, and information. We are not looking outward into the cosmos. We're looking inward from the inside of a cosmic engine that devours information and stretches time. The galaxies spinning in biased directions, just evidence of the greater whirl, and we humans, thinkers, observers, are the only beings trying to understand the machine from inside the mechanism. It's as if a dream began to question the dreamer. Let's go further. If this spin exists, it changes more than cosmology. It changes consciousness. Because if the universe has a direction, what about time? Could time itself be spiraling? Not a straight line, but a helix looping, turning, returning? Could memory, déjà vu, and synchronicity be faint reflections of a deeper rotation in the fabric of existence? Could meaning itself be tied to orientation? Maybe the reason we feel pulled toward certain moments, people, or patterns isn't just psychological. Maybe it's gravitational, cosmic, encoded. James Webb didn't set out to find cosmic spin, it set out to find light. But light, it turns out, carries more than illumination. It carries history, movement, intention, and in the shapes of galaxies, those elegant spirals twirling in frozen grace, it may have found a fingerprint left by the birth of time itself, a spiral that connects every atom, every thought, every soul that dares to look upward and wonder, why does this all feel like it's going somewhere? So the next time you see a galaxy spinning in the sky, know this, it might be telling you a secret, that the universe has a rhythm, that existence has a vector, that you are moving, not just through space, but through meaning, and that somewhere, deep at the edge of understanding, the spin of the infinite is pulling you home. What if black holes were hungrier than the laws of physics allow? They are the universe's most terrifying mouths, not monsters in the night, but gravity, weaponized, collapsing space, swallowing light, an edge of reality where the rules fracture and the known becomes unknowable. Black holes, we thought we understood their appetite. We thought there were limits. But James Webb has just revealed something that breaks the cosmic ledger. Black holes are eating faster than the laws of physics say they should. They are not just consuming matter, they are feasting, and reality is bending to feed them. Let's rewind. According to classical astrophysics, a black hole can only consume material at a certain maximum rate, the Eddington limit. This boundary exists because as matter falls inward, it heats up and emits intense radiation. Eventually, This radiation pushes back against the infalling matter, creating a kind of cosmic braking system. It's like trying to eat faster than you can chew. Push too much in, and it pushes itself back out. But now, James Webb is seeing black holes that ignore the rules. They're growing too fast, too early, and with too much power. Some of them existed just 400 million years after the Big Bang, already as massive as a billion suns. That shouldn't be possible, and yet, here they are. The implications are profound. First, let's address the math. For a black hole to grow this large, this quickly, it would need to collapse directly from an enormous cloud of gas, skipping the star phase, feed relentlessly, with no resistance, or cheat the Eddington limit entirely. And that last one is what's breaking our minds, because Webb is observing quasars galaxies with active supermassive black holes that are blasting out light with such intensity. They should be pushing matter away, but instead, they're still pulling it in. Imagine a fire so hot it should burn your hand if you approach, but instead, it pulls you closer. That's what these black holes are doing. So how is it happening? One possibility: super Eddington accretion. In extreme environments, matter might flow into black holes through narrow, high-density channels, jets, or disks, faster than light can push back. It's like finding a loophole in the laws of thermodynamics. A cosmic side door that lets black holes cheat without breaking the whole house down. But this only raises deeper questions. How common is this? Are these freak anomalies or standard features of the early universe? Did black holes shape galaxies, or did galaxies form around them? Because if the biggest, brightest objects in the early cosmos were already black holes, then the entire story of galaxy formation might be backward. We used to think galaxies made black holes. Now it seems black holes made galaxies. This inversion flips our understanding of structure. We are not built from stardust alone. We are built from the leftovers of gravity's hunger. Every star, every planet, every atom in your body may owe its existence to the appetite of a monster that once pulled the chaos into form. We're not drifting away from black holes. We're the fossilized echo of their feasting. There's something poetic in this. The void, we now know, is not empty. It is a process, a mouth chewing space-time, a heart devouring the present to make way for the future. Black holes are not just ends, they are engines, alchemical crucibles that turn order into entropy and then paradoxically into structure. They are both destroyers and midwives of form. But Webb says even deeper. Some black holes seem to be growing without feeding at all, as if their mass appears suddenly, like a glitch in the simulation. Could they be connected to dark matter halos? Or are they seeded from exotic quantum fluctuations, remnants from inflation itself? Could the early universe have been filled with primordial black holes, some as small as atoms, others as massive as stars? Are we living in a cosmic web, laced with the gravity of a forgotten generation of singularities? And what happens next? If black holes are growing faster than light can fight them, what happens when they reach a critical threshold? Could they merge to create ultramassive black holes, millions of solar masses wider than galaxies themselves? Are they already distorting the geometry of the cosmos, bending paths of galaxies, warping time over billions of light years? And if so, could our entire universe be a byproduct of one of these feasts? Could we be living not in a universe with black holes, but inside the singularity of one? There's a final terror and beauty to this idea. We used to fear black holes as death, but now, perhaps they are rebirth, portals, processes, progenitors. The universe might not just end in black holes. It may have begun in one, and in that case, the next black hole we observe growing too fast, too bright, too early, might be growing a universe inside it. So when James Webb stares into the mouths of these monsters, it's not watching destruction, it's watching creation, a cosmic forge, fueled by hunger beyond reason, the feast of the void, where light is devoured and meaning is born. What if some galaxies were born, already dying? In the great cosmic timeline, there is a rhythm, Stars ignite, galaxies swirl, matter organizes into light and life. But in this delicate choreography, death comes late. After billions of years of star birth, supernova, and recycling, galaxies are meant to live long lives, glowing and growing into elders of the universe. But James Webb has found a terrible contradiction. Galaxies that stopped forming stars when the universe was still an infant. Galaxies that, by all accounts, should be vibrant with youth, but are instead dark, silent, and ancient beyond reason. They are the Galactic Sleepwalkers, coasting through space with all the signs of life behind them and none ahead. And they break everything we thought we knew about cosmic evolution. Let's break it down. Star formation is the lifeblood of a galaxy. It happens when gas cools, condenses, and collapses into bright, burning suns. In the early universe, just hundreds of millions of years after the Big Bang, gas was abundant, temperatures were high, and gravitational chaos was everywhere. This was supposed to be the golden age of star birth. But that's not what Webb sees. Instead, it has detected massive galaxies, some already holding billions of stars, that show no signs of new star formation. They're done, silent, quenched, and the universe, at that point, was barely 1 billion years old. That's like meeting a teenager who already has grey hair, a fading pulse, and no intention of waking up again. This raises deep questions. How did these galaxies grow so massive, so fast? To build such enormous systems in under 1 billion years requires furious, violent activity. Galaxy mergers, hypernovae, inflows of cold gas. But if that happened, why did it stop? What killed them? Theories rush in, feedback from black holes, energy from the central core heating gas and halting collapse. Starburst burnout, an early frenzy of star-making that consumed all available fuel. Environmental stripping interactions with larger clusters that rip gas away. Radiative suppression from nearby quasars. But none of these fully explain the speed or scale. It's like lighting a match in a hurricane. How could it burn so bright and go out so quickly? And then comes the bigger shock. These dead galaxies are not rare. Webb's deep field surveys suggest they are common in the early universe, so common that they rival the population of living, star-forming galaxies. This turns our cosmic timeline into a paradox, because it means death was baked into the beginning. Galaxies that shouldn't exist did. Galaxies that should be thriving aren't. And the early universe wasn't a nursery. It was also a graveyard. We call this process quenching, when a galaxy's star formation suddenly stops. In the modern universe, quenching is expected. Galaxies age, they run out of fuel, they slow down, but Webb is showing us that quenching began far earlier than we thought possible. And not just in tiny, low-mass galaxies, but in giants, cosmic leviathans now gliding in silence. They have structure, they have mass, they have history, but they no longer shine with new life. They are the undead of the universe. And that opens the door to deeper speculation. What if quenching isn't just a physical process, but a cosmic signature of some deeper transformation? What if these galaxies aren't dead, but hibernating? Could some unknown mechanism be preserving them, pausing time within them until a later age? Or could they be victims of cosmic entropy, not because they ran out of gas, but because the rules changed around them? Some theorists propose that variations in dark energy or early quantum fields could have created patches of space-time with different thermodynamic behavior, areas where entropy spiked prematurely, silencing star formation. If true, these galaxies are echoes of an asymmetry in the universe's infancy, a rift, a scar, a ghost. There's also the human question. We tend to see galaxies as distant mechanical things. But what if they are more like organisms? They grow, they feed, they age, and sometimes they de-young. Looking at these early quenched galaxies is like discovering a fossil record of beings that lived too fast and burned too brightly. And it forces us to ask, what is the purpose of a galaxy that forms, blazes, and dies before the universe has even stabilized? Is this death a flaw, or part of some deeper rhythm we don't understand? If galaxies can die early, can others awaken late? What else lies sleeping in the cosmic dark? The James Webb Telescope was supposed to show us the first light. Instead, it's showing us the first silence. A silence that arrived too soon. A silence that's too loud to ignore. Galactic sleepwalkers drift through space as monuments to forgotten rules, or reminders that our models of cosmic time are still crude sketches, drawn in chalk on the walls of infinity. And maybe, just maybe, their quiet is a kind of message, not of death, but of restraint, of mystery, of patience. Because in a universe 13.8 billion years old, a billion-year nap may not be the end. It may be the beginning of a new kind of cosmic story. What if planets could exist without stars? In our minds, planets orbit stars. That's the rule. The Sun has Earth. Alpha Centauri may have rocky companions. Where there is light, there are worlds. But James Webb has shattered that expectation, revealing orphaned planets adrift in eternal darkness. Worlds with no home, no sun, no center. And stranger still, some of them are raining metal. These are not myths or sci-fi fantasies. They are real, and they live in the abyss between starlight. Webb's instruments, sensitive to the faintest warmth and trace gases, have detected planets not tethered to any star, free-floating giants, dozens in a single cluster, wandering the void like cosmic ghosts. And on their scorched, chaotic surfaces, storms rage with vaporized iron, sand, and molten rock. Imagine clouds of liquid metal. Imagine rain that falls as molten glass, evaporates mid-air, and condenses again in endless cycles of fury. This is not weather, it is alchemy in motion. Let's name one of them. PSO 322, a rogue planet we tanta light years away. No star, no sunrise. Its sky is a swirl of iron clouds, glowing from internal heat. Temperatures soar to 1,800 degrees Fahrenheit. Wind speeds cross 1,000 miles per hour, and in the absence of a sun, its atmosphere generates its own storms, powered by leftover heat from its violent birth. This planet is alone but far from lifeless. It is a furnace in exile. Now Webb has taken this a step further. In star clusters like Trapezium, it's discovered pairs of rogue planets, two worlds bound not to a sun, but to each other. Like lovers dancing in the dark, they orbit one another as they drift through space. This challenges our most fundamental assumptions about planet formation. How did these worlds form? Were they ejected from young solar systems during chaotic interactions? Or did they form in isolation, like stars but never gained enough mass to ignite? Either way, the result is a new class of planetary object. Not star, not planet, something in between. And it gets weirder. Some of these free-floating planets have atmospheres. Webb has detected carbon monoxide, methane, and even traces of water vapor on worlds where no sunlight shines. These elements shouldn't exist without external energy. And yet, they do. Perhaps they are heated by tidal forces, twisted by unseen moons, or binary companions. Perhaps radioactive decay warms their cores. Or maybe they are relics of a primordial era, still glowing with the energy of creation. We don't know, but what we do know is this. Planets do not need stars to burn. Let's talk about metal clouds. Webb has identified clouds made not of water, but vaporized rock, magnesium silicate, aluminum oxide, iron. Imagine an atmosphere where the clouds are mirrors, reflecting not sunlight, but their own incandescent glow. Lightning arcs through these heavy metal skies, frying molecules into exotic compounds never seen on Earth. When it rains iron droplets, and that rain doesn't cool. It heats the lower atmosphere, creating a convection system unlike anything in our experience. This isn't weather, this is atmospheric violence in its purest, most beautiful form. Why does this matter? Because it shows us that planetary habitability is more diverse than we dreamed. Life, if it ever exists out there, might not need sunlight, might not need orbits, might not need Goldilocks zones. Maybe life forms on rogue planets, drawing heat from chemistry instead of photons. Maybe there are ecosystems under iron skies, thriving in pressure and shadow. Or perhaps these are worlds beyond life, not meant to host biology, but to challenge our understanding of what it means to be a world. There's something profound in the idea of a planet without a star. It reminds us that isolation is not extinction, that even in the darkest reaches of the void, something can take shape, grow, burn, storm. These planets are cosmic orphans, but they still dance. Their atmospheres rage, their cores pulse, their magnetic fields reach out into emptiness like searching hands. They do not orbit, they drift, carrying with them the memory of a system that rejected them or a dream that never became a star. And yet, they are beautiful. One day, we might send a probe, or even land there. We'll descend into metallic skies, listening to the hiss of iron wind, watching molten rock fall like starlight. We'll study the chemistry of atmospheres forged in solitude. We'll measure the pulse of warmth that comes not from above, but from within. And perhaps we'll realize these worlds, untethered as they are not tragedies. They are testaments to the universe's ability to create meaning in the absence of order, to build structure without a center, to give birth to wanderers. What if galaxies could bleed? In deep space, beauty is often violence slowed down. A spiral arm isn't just a shape, it's a record of gravitational trauma. A glowing halo isn't just light, it's a wound still radiating. And now, James Webb has given us a front row seat to the anatomy of galactic destruction. In the cosmic zoo, two creatures have emerged. The Cosmic Owl, a galaxy with hollow eyes and a shredded heart, and the Jellyfish galaxy's stellar beings torn apart, trailing long, glowing tentacles. They aren't metaphors. They are real galaxies, caught in the act of being stripped, shredded, and disassembled by the cosmos itself. Let's begin with the jellyfish. These galaxies have names, numbers, but that doesn't do them justice. They look like they're swimming through space, trailing streams of gas and stars behind them like tentacles. But what you're seeing is suffocation. It's called ram pressure stripping. Imagine a galaxy diving into a cluster, a sea of hot, X-ray emitting gas. As it plunges, the pressure of that medium acts like a wind, blasting away the galaxy's own gas reservoir. Stars remain, but the raw material for making new stars, hydrogen and helium, is torn out behind it. It's like yanking the lungs from a living creature. The galaxy keeps moving, keeps glowing, but it's dying. Starvation has begun. Now the Cosmic Owl. James Webb captured this haunting form. Two luminous, symmetrical eyes, a central void like a missing soul, and arms splayed in every direction. The resemblance to an owl is eerie, yes, but more importantly, it's impossible. This galaxy is in mid-transformation. The symmetry hints at a collision, perhaps a head-on galactic merger. But the emptiness at its core? That's not normal. There should be a bustling bulge of stars. Instead, it's hollow, like something ripped out its heart. Scientists believe this may be evidence of galactic cannibalism, where a larger galaxy absorbed a smaller one, and the violence was so intense that it left behind nothing but a glowing outline and empty eyes. These events aren't rare. Webb has revealed they're happening all across the universe, especially in galactic clusters, where gravitational tides pull galaxies into fatal proximity. Galaxies are not islands. They are part of a web, a violent, dynamic ecosystem, where size is survival, and the price of closeness is often death. But why does this matter? Because every galaxy is a story of balance, between gravity pulling in and pressure pushing out, between creation and decay. These jellyfish and owls, they are what happens when that balance collapses. They remind us that structure is fragile, that form is temporary, that even the most majestic spirals can unravel like thread. There's something heartbreakingly human about this. These galaxies are not destroyed in a single instant. There's no explosion, no detonation. Instead, they are slowly erased, stripped of identity over millions of years. It's the long goodbye of the cosmos. Imagine watching a friend forget their name, forget their home, forget their purpose, until all that remains is shape and movement, without meaning. That's what Webb is capturing. Galactic dementia. And it makes you wonder, is the universe trying to remember something it's already lost? Are these wrecked galaxies echoes of a forgotten order? Or are they simply the cost of evolution, the deaths that allow others to rise? There's also something deeply poetic in the way these galaxies react. Even as they are torn apart, they create beauty. The jellyfish tails glow. Star formation ignites in the stripped gas. New stars are born from the wreckage. Destruction becomes art. Pain becomes pattern. The galaxies may be dying, but they are giving birth on the way out. It's cosmic altruism, the universe consuming itself so it can keep becoming itself. And what of us? We are made of stars, but not just any stars. We are made of stars born in chaos, in collisions, in these very acts of cosmic violence. Our atoms were likely forged in galaxies that once bled gas into intergalactic space, sacrificing themselves to feed the next generation. If galaxies are gods, then these are their crucifixions, and we are the resurrection. One day, the Milky Way will suffer a similar fate. It will collide with Andromeda. Spiral arms will twist into knots. Cores will merge. Stars will scatter. We may become a jellyfish. We may become an owl. Or perhaps we already are. Already caught in a process so slow, we mistake it for stillness. But Webb sees what we cannot. That the universe is always moving, always unmaking, always remaking itself. So the next time you look at a nebula, or a spiral arm, or a galaxy in deep field, remember this. It might be smiling, it might be dying, it might be both. Because in this universe, beauty is not the opposite of violence. It is its shadow. What if the early universe was older than it looked? We thought we knew the script. The Big Bang, a sea of hydrogen and helium. Then darkness. Then, slowly, over hundreds of millions of years, the first stars ignite, fusing light into matter. Then come the heavier elements, carbon, oxygen, iron born in supernovae scattered across time. That's how the universe builds its complexity. First simplicity, then chaos, then structure. But James Webb is tearing that script apart because it's finding something impossible. Young galaxies filled with old chemistry. The first stars, what cosmologists call population 3, should have been pure, no metals, no oxygen, no carbon, just the primordial building blocks, hydrogen and helium. Their deaths, in theory, seeded the universe with the raw material for the second generation, and that second generation created the third, the fourth, until eventually you and I. But Webb is detecting galaxies less than 300 million years after the Big Bang that already contain iron, oxygen, carbon, neon, magnesium, not in traces, in abundance. It's like finding a newborn who somehow already carries the scars, memories, and fingerprints of their ancestors. It defies logic. Let's slow down. When astronomers speak of metallicity, they're not talking about metal in the way we think of steel or iron bars. In astrophysics, metals mean any element heavier than helium, the stuff of stars, planets, and life. Webb's instruments have observed high metallicity galaxies at redshifts above 10. That means we're seeing them as they were when the universe was only 300 to 400 million years old. Yet these galaxies have chemical fingerprints that shouldn't exist for another billion years. It's like walking into an ancient ruin and finding a skyscraper with working lights. So where did this complexity come from? Option 1. Maybe star formation began earlier than we thought, much earlier. Instead of taking hundreds of millions of years for the first stars to form, maybe they ignited just tens of millions of years after the Big Bang. That would compress the timeline of cosmic evolution, forcing us to redraw the entire early history of the universe. Option 2. Maybe these galaxies underwent rapid, violent starbursts, forming and dying in waves so intense they accelerated chemical enrichment. But here's the problem. That kind of furious activity should leave behind chaos, irregular shapes, massive outflows, extreme radiation, yet Webb shows us structured, organized galaxies, spirals, disks, even bulges far too refined for their age. It's the paradox of premature order. How can something so young look so mature? And this isn't a one-off. It's not a single anomaly we can explain away. It's a pattern, galaxy after galaxy, star after star, all whispering the same contradiction. The early universe was not simple. It was not quiet. It was not slow. It was metal-rich, complex, alive with fire, and that changes everything. Here's why it matters. The formation of metals is the foundation of everything we call home: carbon for life, oxygen for breath, iron for blood, silicon for planets, phosphorus for DNA. If these elements existed much earlier than we thought, then the conditions for life may have arisen far sooner. It means that the cosmic clock is off, that the chance for biology may have arrived not 10 billion years in, but 1 billion. It opens the door for ancient life, long vanished. Civilizations formed in the first billion years. Cultures erased by entropy, black holes, or the quiet dark of intergalactic space. This isn't just chemistry. It's potential. And then there's the deeper mystery. What if this premature chemical maturity is telling us something even stranger? What if our models of stellar evolution are missing a piece? Perhaps the first stars weren't as simple as we thought. Maybe population 3 stars didn't all explode. Maybe some collapsed silently into black holes, while others lived longer and created metals in new unknown ways. Or maybe the laws of physics weren't always the same. Maybe fundamental constants like the speed of light, the strength of gravity, or fusion thresholds were slightly different in the early universe. A microscopic tweak would change everything. It could mean faster burning stars, more efficient fusion, or even new kinds of stellar reactions we've never witnessed. What we're seeing may not be just the first galaxies. We may be glimpsing a different regime of physics, a pre-standard universe, an age where the rules were being written in real time. And what if that old chemistry was seeded from somewhere else? A cosmic infection, a transfer of heavy elements from a prior universe, or an older cosmic cycle? If the Big Bang wasn't the beginning, but simply a reset, in that case, these ancient metals would be fossils, not of stars, but of something far older, another reality, another iteration, another script entirely. It's dizzying to think that as we look deeper into the past, we're not seeing simplicity. We're seeing maturity before its time, stars that shouldn't exist, elements that shouldn't have formed, galaxies that lived fast, died young, and left behind puzzles in the shape of starlight. And in that light, we see our own reflection, because we too are creatures of paradox, ancient atoms arranged in fragile flesh, children of the cosmos, carrying the memory of explosions we never witnessed. We're made of iron that formed before Earth existed, oxygen older than the solar system, calcium that passed through the core of forgotten stars. And now Webb is showing us just how early those pieces began to fall into place, not in the middle of time, but almost at the very beginning. What if the universe wasn't expanding into nothing, but collapsing into itself? At the edge of knowledge, the universe begins to look like a riddle whispered by something ancient and unspeakable. We've traveled through galaxies torn apart like jellyfish in the tide, through rogue planets raining molten iron, through stars too old for the universe they live in. And now we arrive at the fracture, the crack beneath reality, the question that silences even the most brilliant minds. What is the universe expanding into? And what lies beyond the veil? The answers, if they exist, are terrifying. Some physicists now suggest we may not be inside a universe at all, but inside a black hole. Let that sink in. Not orbiting one, not near one, inside, not metaphorically, literally, what we call the observable universe galaxies, stars, cosmic microwave background, may actually be the interior of a black hole formed in some higher dimensional space. And everything we know, time, matter, light, laws of physics, is simply what happens when something falls into infinity and keeps falling forever. This idea isn't science fiction. It's rooted in equations. Black holes have three key properties. They have entropy, a measure of information inside. They have temperature, they radiate. They have horizons, boundaries beyond which nothing escapes. Our universe has all three. A cosmic entropy budget, a background radiation, glow, an expanding horizon beyond which we cannot see. It's as if we're living inside the mirror image of a black hole. And if that's true, then the Big Bang wasn't an explosion from a singularity. It was a bounce, a collapse from another universe, a white hole event, the outflow of information from a cosmic death. But it gets stranger. At the smallest scales, beyond atoms, beyond quarks, space and time may not even be smooth. Quantum gravity theories suggest the fabric of space-time is not continuous, but made of discrete chunks, Planck-scale pixels, flickering like foam. This is quantum foam, a seething sea of mini black holes, wormholes, and probabilistic tunnels, a chaos so deep that time becomes meaningless. Cause and effect break down, and in this foam lies the possibility that reality is unstable, that space-time can collapse, that a quantum fluctuation could trigger a vacuum decay, destroying the universe at the speed of light. No warning, no survivors, just a different state of physics, one where atoms, stars, life can't exist. But there's another fracture, a gentler, more poetic one. Some theories suggest that the universe may not die in a bang or a freeze, but in a bounce, a cyclic loop, that after trillions of years of entropy, the fabric of space-time could stretch so thin that it snaps back, a new Big Bang, a new arrow of time, a new script written in the ashes of the old. This is the ekpyrotic universe, the phoenix model of cosmology. It doesn't fear death. It expects it. It embraces the rebirth that follows. And if that's true, then this entire universe, all 13.8 billion years of it, might just be one frame in a film with no beginning and no final scene. But there's one more crack, and it's in us. Because as we stare into the cosmos, we're also staring into ourselves. Every time we peer deeper, into redshifts, radiation, particles, gravity, we come closer to a realization. We are not outside the mystery. We are inside it. We are the mystery itself, gazing at its own reflection. Think about it. What created the Big Bang? We don't know. What lies beyond the observable universe? We don't know. What is time made of? We don't know. What is consciousness? Still, we don't know. Every path we take, from string theory to quantum loop gravity to cosmic inflation, brings us closer to a wall, a silence, our veil. It's not ignorance, it's design. Maybe we are not meant to solve the universe. Like a puzzle, maybe we are meant to experience it. Like a poem. And so we return to James Webb, not as a telescope, but as a mirror, because everything it sees, galaxies, stars, orphans, voids, already lives inside us. The iron in our blood was born in the heart of stars we will never know. The atoms in your hand have traveled through black holes and solar winds and ancient gas clouds, older than light. And the questions we ask are not just scientific, they are existential. What does it mean to exist in a universe that creates itself? What does it mean to feel awe in a cosmos that may not care? What does it mean to matter? So this is the final fracture, not in galaxies, not in stars, but in certainty, a beautiful crack through which wonder spills in. And maybe that's enough, not to understand the universe, but to stand in its presence, to look at the darkness and whisper, "I see you."